Hi guys, in this video you'll learn about what internal and external validity is, why it's important, some threats to both internal and external validity, and then I'll give you lots of examples so that you can look for yourself and think about what makes a high quality study. This is where this video fits into the context of our whole course and of the research process. So a few weeks ago, we talked about measurement validity, which is the extent to which a measuring procedure measures what it intends to measure. This week, we'll be talking about validity on a larger scale, the extent to which the whole research study is valid. We'll be talking about whether the conclusions of a study accurately follow from what was actually done. So how well does that research study actually address the questions it set out to address? Did the conclusions apply to other people or groups of people who weren't tested? Research, internal and external validity is about what makes a study flawed or what makes a well-designed study, and how can we decide on the quality of the study. So let's get started. Let's first start over here and talk about what is external validity. So external validity is the extent to which we can generalize the results of a study to people, places, times, features of the study that weren't used in that particular case. A threat to external validity is any feature of a study that limits our ability to generalize the results of the conclusion. So if you remember last week, we talked about how the goal of a study is to generalize the results from a small sample of participants to our larger target population. We want to recruit a sample of participants that is representative of the target population so that we can make those generalizations. So a threat to external validity is any feature of our sample that makes it non-representative. Internal validity is the extent to which we can be sure that there is one unambiguous explanation for the relationship between two variables. A threat to internal validity is any factor that allows for an alternative explanation. So in the last video by Jonah, he talked about various research strategies and said that only the experimental research strategy allows us to establish cause and effect. This is because experiments control for possible compounds so that we can be sure that the relationship between the two variables is the only explanation for our results. So let's go on now into a bit more detail. We'll start with external validity, then we'll move on to internal validity. We'll talk about all the different kinds of threats to both of them and how we can create a higher quality research study. So let's start with external validity. Last week, I gave you the example of, imagine we were interested in studying the effect of class size on kindergarten kids' early literacy skills. We said that it was important to recruit a sample of participants that was representative of our target population, that had the same ratio of boys to girls, participants had similar ethnic and social economic status background as kids that in general that live in Niagara. We also talked about how quota sampling is better than convenience sampling to ensure a more representative sample. When we have a more representative sample, we are more likely to have higher external validity. Here's this in another visual. Imagine our target population involved blue shirts, green shirts, and various sizes of shirts. If our sample only involved blue shirts, then we would have a biased sample. A representative sample would be a sample of participants that involve both green shirts, blue shirts, and different size shirts. So to meet this criteria of external, having high external validity, we have to be able to make three kinds of generalizations. The first is what we've just been talking about, where we can generalize from the sample to our target population. To do this, we want to avoid selection bias, only selecting people that volunteer to be in our study, only selecting high achieving university students. Quota sampling is how we can achieve this. If we are aware of the different subgroups within the population, then we can go out and make sure that our sample also represents those different subgroups. Another generalization that we want to make is being able to generalize the results of our particular study to other studies and other procedures. So we want to avoid any effects that are specific to our particular study. For example, being a novelty effect is when people's performance is different just because they're excited about being in the study, fatigue and practice effects, or any effect that's specific to the experiment or testing procedure. Possible solutions to this are to vary a procedure. For example, have multiple examiners or multiple tests to be sure that our results that we achieve can be generalized to those different tests and the examiners. Finally, we want to be able to generalize from our research study to the real world. We don't just care about how people perform in the lab, we want to know how they perform in more real life situations. So we want to avoid any tests that are specific to a certain test, time of the study, or come merely as a result of being studied. Possible solutions to this are to collect data at multiple time points. This would allow us to be sure that our results are not specific to a particular time that we test people. Another solution may be that rather than using an experiment, we may want to shift our research strategy. Descriptive, correlational, and non-experiments tend to examine variables in their more natural real-world settings, and so they tend to have higher external validity than experiments. Although there are ways that we can increase the external validity of an experiment, we'll be talking about that more in week 7. Okay, now let's talk about internal validity. It's the extent to which our study produces a single, unambiguous explanation for the relationship between two variables. If you recall from Jonah's video, the goal of an experiment is to establish a cause and effect relationship between two variables. And as a result, it's more likely to have high internal validity because experiments involve more rigorous control. All other studies will tend to have low internal validity because they don't intend to answer that cause and effect questions about the relationship between two variables, and so they don't involve the same degree of control. So correlational studies, descriptive studies, non-experiments, although they tend to have higher external validity, tend to have lower internal validity. So how can we be sure that there is only one explanation for the relationship we find between variables? Well, we want to make sure that extraneous variables, so these are variables that we don't care about, that we're not measuring, are not confounds. And a confound is any extraneous variable that systematically differs between our groups or our conditions, and also can provide an alternative explanation for our results. Not all extraneous variables are confounds. The extraneous variable has to systematically be different between conditions or groups and provide an alternative explanation for the results. So your textbook gives an example on page 141. I encourage you to read this. Suppose a clinician wanted to study the effect of a particular treatment for depression. And what they found is that depression scores decrease over the course of the treatment. However, if they also found that the weather also changed around this time, this would be a confound. You wouldn't know whether it was the treatment that causes the change in the depression or if it was the weather. And weather in this case is a confound because it would systematically change between time 1 and time 2. And we also know that weather has a large impact on people's moods. As a side note, this would also be a threat to external validity because we wouldn't know if the results from our therapy would generalize to other conditions. So a possible solution to this problem would be to involve a control group where they're tested at a time when the weather didn't change. And this would allow us to see whether the weather actually explained our results. Let's give another example that's maybe more relevant for you. Suppose we're interested in the effect of mindfulness training on improving kids' executive function skills. We want to know if training causes improved executive function skills. Suppose we recruit a sample of participants and we randomly assign them to either receive mindfulness training or a control condition where they receive study skills training. We then look to see whether the executive function skills are different between two groups. Let's talk about some possible confounds that we need to be aware of. Well, there's 3 different categories. Confounds can fall into the category of variables in the environment, variables that exist between people, or variables related to time. Let's go into detail about those now. So environment variables could potentially be a confound. If 2 treatment conditions are administered in different environments, then that environment could be a confound. So if our mindfulness training group always met in a really brightly lit room with yellow paint on the walls and brightly colored pictures on the walls, and our control group was in the basement where it was dark and dank, we wouldn't know if this would be a confound. If we found a difference in executive function skills in our mindfulness training group, we wouldn't know if it was the mindfulness training or if it was features of the environment, the color of the walls and the fact that there was no light in that other group. If those conditions in the environment systematically differed between groups and could potentially impact the children's executive function skills, then this would be a confound. To avoid this, we would want to make sure that the environment was the same in both of the conditions. The next possible threat to internal validity is about individual differences in the participants. If we had two groups of participants, our mindfulness training group and our control study group training, and features of those participants were noticeably different between the two groups, then it could be those differences that explained their difference in executive function skills and not the training per se. So for example, if our control group had kids that scored higher on a test of ADHD symptoms, then this would be a confound because the groups would differ in that. And we wouldn't know if it was the training or if pre-existing differences in the kids themselves explained their differences in executive function skills. Finally, imagine we only tested one group. If we only had our mindfulness training group and we tested them at the beginning of the year and after a whole year of training. If we found difference between groups, we found differences between time 1 and time 2, we wouldn't know if it was the training that caused the difference or if something related to time and the fact that the children were a whole year older could be a confound in explaining the results. So we're going to be talking about this more in future weeks and talking about possible solutions to all of these confounds and possible threats to internal validity. So stay tuned. I'm going to give you a couple examples, and I'd like for you to pause the video here, read the examples, and think about if you can find some possible threats to external and internal validity. Why don't you go ahead now and pause the video. Okay, hopefully you paused it and now you're back. Let's talk about some possible confounds and some threats to external validity. Well, here in this study, we are looking at seniors, but we've got a non-representative sample of participants. We're only really testing female participants. We wouldn't know whether our results generalize to male participants. This would be a threat to external validity. Now let's look at this conclusion. Brain training games improve memory in the elderly, may even offset Alzheimer's. Well, we never tested anybody who is at risk for developing Alzheimer's. So this is another threat to external validity. We don't know whether the results of this study with healthy older adults would generalize to people who are at risk for developing Alzheimer's. Let's talk now about threats to internal validity. You might notice that memory was tested only at the end of training. It wasn't tested at the beginning of training. Without a pre-training testing session, we wouldn't know if there was pre-existing differences in those seniors' memory skills between the ones that were in the luminosity group versus those that were in the control group. And without knowing if there was pre-existing differences, this could be a confound and a threat to internal validity. Let's do another example here. This one is about a kindergarten literacy program. Why don't you pause the video here and see if you can answer this question. Are the conclusions valid? Pause the video here. Okay, we're back. This is a problem if all of the kids in the new program are tested in the morning and all of the kids in the old program are tested in the afternoon. This is a confound. The environment differs between testing in both of the groups. It could be that kids perform better in the morning than they do in the afternoon. By the time they get to the afternoon, they're tired. And so we wouldn't know if any differences in children's scores reflect the time at which they were tested, which systematically varied between those groups and is a confound, or if it really was this new literacy program that enhanced the kids' skills. So this would be a problem, and we would want to control for that to increase the internal validity of this study. So it's all about a balance between internal and external validity. To control for all possible compounds, a study must have more tight controlled. However, this being in a more tightly controlled situation also moves it further from real world situations, which could be then a threat to the external validity. Quality research is about balancing the threats to both internal and external validity, identifying the most serious potential threats, and doing what you can as a researcher to avoid them. It's okay not to control for everything, you just have to be honest about it. So when you go ahead and do your own research proposal, you want to think about which possible threats you want to control for and explain your choice and your justification of why you're doing things in certain ways. Similarly, when you're reading research studies, in particular, you want to look at what kind of research strategy they used and whether the conclusions that follow from that research strategy is actually what they can conclude. Similarly, you want to look and see whether it's possible for the results to generalize to other people, places, contexts that weren't studied. Remember, descriptive, correlational, and non-experimental studies tend to have a high external validity but low internal validity, whereas experimental studies, it's vice versa. They tend to have high internal validity but low external validity, and quasi-experiments tend to fall somewhere in the middle. So here it is a schematic. If you're more of a visual person, you can think of this as a continuum between high internal and external validity, where experiments particularly with their random assignment will follow higher on that internal validity, but as a result fall low on external validity, and quasi-experiments will fall somewhere in between. So it's not about which strategy is better or worse, it's about choosing a strategy that best allows you to answer the questions that you set out to address. Now I'm going to end this by showing you an example of a study that tried to do the best of both worlds, and they were able to have their cake and eat it too. They wanted to try to design an experimental study that had high internal validity but also had high external validity. So in this study, they wanted to know whether sports fans can influence the scores that Muay Thai judges give regarding the Muay Thai fighter's performance. So in this study, they wanted to still do an experiment so that they could have enough control to be confident that one thing causes another, but they also wanted to design it in such a way that they could be confident that the same effect would happen if other people or contexts or places were tested. Let me show you what they did. So in this study, they recruited participants to be judges, and these judges were randomly assigned to either be in one of two conditions, a crowd noise group or a crowd no noise group. In the no noise group, they simply wore headphones and couldn't hear what whether the crowd was cheering for a particular fighter or not. Versus in the noise condition, they didn't wear those headphones, and so they could hear whether the crowd was cheering more loudly for a particular fighter. All other features of the study were controlled, so all other features were exactly the same between the two conditions. So as a result of this randomly assigning judges to the two different groups and controlling for possible compounds, we can be sure that the study has high internal validity. Now, they also wanted to be sure that the results would generalize to other people, places, contexts that weren't tested, that could be tested in other situations. So whether it had high external validity. So what they did to do this was they they had this experiment happen in multiple different conditions with multiple different people and across different times. So by having different size venues with different sizes of crowds, they could be sure that their results would generalize to different venues and different events. They recruited people to be the judges that varied in their experience in being a judge so that they could be more confident that the results would generalize to different people. And then finally, they had the experiment carried out over the course of a year so that they could know that the results would generalize not just to that one point in time when they did their experiment, but more likely generalize to multiple points in time. So I encourage you to check out that study. I think it was really well done, and I provided a link down at the bottom. It will also help explain the difference between internal and external validity and why it's important to try to have high levels of both. So to summarize, research validity is about how true or accurate the conclusions of our study is. Any factor that raises doubts about the results or the interpretation is a threat to validity. A study has high external validity if results can be generalized to people, places, conditions, times that weren't tested. And a study has high internal validity if there's one unambiguous explanation for the results. Confounding variables are a threat to internal validity, and we want to do what we can to avoid confounds. To summarize Jonah's lecture, he also talked about different research strategies have different goals and allow us to make different conclusions about the variables we're interested in. The research strategy you select depends on what you want to achieve. Only well-designed experimental research studies allows us to conclude that one variable causes another. And so only experiments tend to have high internal validity. Thanks so much for listening. We'll see you next time.